All right, to make the connection between simulation, probability, and probability distributions, I have here a simulator. This comes from distributeme.org. I'm not actually sure how to pronounce that because I've never heard it pronounced. This is a website that has a few different free simulators where you can examine different kinds of probability distributions that are organized based on type. So in the previous video, we talked about discrete uniform distributions, and this is an example of a different distribution that we'll cover in detail in a later section. For now, I just want to illustrate the connection between between taking these random outcomes and their probabilities and how they're represented in terms of the distribution. So, in other words, we're making a connection now between the frequentist probability and the classical probability. So, to understand how to work with this simulator, okay, I'm going to show you now what these buttons do. So the first button, which is the play button, will just generate one random outcome. So we ran it once, and it gave us a random outcome of x equals 10. Now the range for this specific random variable is from 0 to 20, so we won't get 21 or anything beyond that. We're only going to get values between 0 and 20. And what the blue graph is telling us is this is the probability distribution. So this tells us the likelihood of all the different outcomes classically. And as we run each simulation, each outcome has a probability of occurring corresponding to the height of that bar. So the height of this bar is about 0.18, which means we had an 18% chance of obtaining this at random any given time. We're going to assume that each run is independent so that there's no, oh yeah, this one depended on what we got, but in the past, no, each outcome is obtained independently of each other. So this is one simulation, but we can obtain a few more if we want. So we'll run it again. This time we got 10 and 11. So we now have 3 random outcomes. And we can run it again several times until we get to our desired sample size. So I'm going to go to 15. So now I have a sample of random outcomes, of random values. We'll see that 10 appeared a couple of different times, so did 9, 8. We even got 6, and we got 11. And from these data, we can compare the relative likelihood or the relative frequencies of the values that we obtained and compare that to the actual probability that we're going to obtain in the long run. And just want to show you, to make the connection, if you scroll all the way back down to this, we'll see that there's 2 categories here, one that says mean and one that says standard deviation. And on the right, so the right column, that's actually the sample mean and the sample standard deviation of the random outcomes themselves. So the random outcomes we got in the 15 runs of the simulation gave us a sample mean of 9.8 and a sample standard deviation of 1.74. The first column is what we would call the theoretical mean and the theoretical standard deviation. We're going to cover these in detail in the next section, but they're a generalization that allow us to think about population mean and population standard deviation in probabilistic language. We're going to have different names for them, but that's what they eventually mean. Which means if we run this many, many times, so what I've just done is I've selected in this drop-down ribbon 10,000 simulations from this experiment. So I'm going to reset, and it's going to run 10,000 times, and I'm going to press the fast forward button so it'll do it all at once. And you'll notice that the red bars, which represent the relative frequencies, are getting closer and closer to the heights of the blue bars, which is the actual probability distribution graph. In other words, what we're getting here is the relative frequency distribution in the long run approximates or gets closer to the probability distribution. So the connection there is the frequentist probability is telling us that we're getting closer and closer to the classical probability, and our estimates for this sample data distribution, its sample mean, its sample standard deviation, the skewness, the range, all of that is getting more and more accurate in terms of what the probability distribution is predicting for us. So we've just about hit 3,000 runs here, which is a substantial amount, and you can go even higher if you want. But in the long run, then you'll notice that looking at the relative probabilities, the relative frequencies, they eventually home in on what the actual probabilities are. So we'll stop there. And so in the next section, we'll talk about how these predictions actually line up and what we can take away from our previous study of sample data.